All good? All right. So, thanks for your patience. Welcome to my talk about migrating containers on Kubernetes. I had a snowboard accident last week, so this is a bit rushed. So, quick recap for probably all of you who don't know what ZeroPod is. So, ZeroPod is a new container runtime that I've been developing. It basically uses snapshots. Process snapshots to snapshot unused containers to disk and then restore them on use again. So you can, it can restore containers in sub-second delay once a request comes in. And it's basically just to save on resources for unused infrastructure. So let's say you have 100 pods on a node, maybe 50 pods of 50 pods on this node are rarely used, maybe once a day, maybe 5 times a day, doesn't really matter. ZeroPod will take care of snapshotting it when it's not in use for a specified amount of time. You can watch my talk I gave at the Kubernetes Community Day last year. This just introduces ZeroPod by itself. But yeah, there was one big issue, or like one topic that came up. I think it was also asked at this presentation. What basically happens if your full node dies that had such ZeroPods on it? Now you have the problem that you're basically over provisioned quite a bit, right? So all these pods need to fail over to new nodes. So now, depending on the environment, your autoscaler might spawn 2 or 3 new nodes just to allocate these pods that have died. And then after some time, they will scale down to 0 again, so it will scale down the nodes again. So you have this sort of, what is it called? The Hamburger effect? I don't know the English word. But yeah, you have this sort of scaling effect that will happen. And yeah, looks kind of like this, where containers get stuck. So one idea, we could just migrate these containers to other nodes because we already have the snapshots on disk. That's what it does, right? ZeroPod takes a snapshot of the whole process tree. It stores it on the disk, on the local disk. So you would just simply need to transfer these to the new node, and then you could even, the new container would not even need to start. You could just wait there for requests, and all the state would be transferred because the in-memory state was dumped. So that's at least the idea. So yeah, I'll quickly show that. Hopefully it installed. So I had to set up a new cluster just now. Get runtime class, that's always the thing to check. Yes, it's installed. So I think it should work. So what I have here is just a local kind cluster. For demonstration purposes, this should work on any Kubernetes cluster, depending on some things I will talk about later. But theoretically, you can just install this on any Kubernetes cluster. And as I've said, it's a runtime, so it's exposed as a runtime class. So if you're familiar with Kubernetes in your pod, you can basically say runtime class and then specify a handler for this pod. And this will make sure that your pod is being created or handled by ZeroPod. And I have this demo 1 YAML here. It's just a really simple deployment. It's called Freezer. I'll explain why later. And it has, as I've said, here it has the runtime class ZeroPod. That's the only thing that makes this a special pod, essentially. And some annotations, but yeah. And then I have a service, and it's just a node port, so I can show you this. I'm just going to apply this. Demo 1. So it should start up here once it's able to pull the image. And yes, Okay, I'm really glad that works. So here, this is what this pod returns. It's just a little JSON. It has a timestamp with the last request and last freeze duration. Don't pay too much attention yet, and data. So this is just to show that we can retain data. So I can now do a post request, and I'll just post this data to the service. So the process now has stored in data hello TTT. So this is just to show the persistence. And up here, I'll just do this, show labels. So ZeroPod will actually tell you via labels the state of the container. So I now see this is scaled down. And if I make a request, you see it is running, and after 5 seconds, it will scale down again. And this is, you basically don't notice it, right? But it checkpoints it to disk and restores it that quickly. You see the last freeze duration. This is, I think, microseconds, but it's like 150 milliseconds. Oh no, actually it counts how long it was scaled down, so it doesn't really make sense in this scenario. But anyway, what we also have is these migration objects. So we said we want to migrate these scaled down pods somehow, right? So let's assume this node has 100 of these. And I actually need to check on which node this is running. It's running on the TTT worker, and I have 2 workers here. So now I'm going to go ahead and simulate like a drain. So let's say there's maintenance, you want to drain this node completely, and you want all the pods to fail over to another node. So as soon as I issue this statement, you should see a new migration appear down here, and a new pod will be scheduled on the new node, and it should start in scaled down state. Yes, you can see it's pending. It needs to download the container image. That's why it took a bit. And it's a bit hard to see because there's lots of output. But you see here container creating, and it started in scaled down state, essentially. And I can also show you this. So if I go to the second node and just look at my process tree, I just see the ZeroPod shim here. This is the container runtime shim, and there's no process below it. And if I again do a get, my data is still here, and now the process is running. So it stored the data. It stopped again. So it stored the data, it migrated from one node to another node, everything is retained. So that's the offline migration. Here's a little diagram. How does this work? So we have the node A. Here is where we demonstrated the old pod. We deleted that pod by draining. You can also just delete the pod. What will happen then is the shim is actually ZeroPod in this case. It will talk to another component of it, the node component that's present on every node. This node component then will know this is okay, you want to evacuate this node. So it will create that migration object that you've seen. And then the fresh pod that spawned on the other node, it will also contact ZeroPod node on start and notice, oh, there's a matching migration. So I don't need to start fresh. I can start with the migrated state. And yeah, it claims that migration, so it can only happen once. So you don't run into weird issues. So this is all coordinated by the Kubernetes API. And yeah, make sure that you only one pod can migrate to one pod, and not sort of weird scenarios where 3 pods would claim the same migration. And then all it needs to do is pull that image. And so far it's just making an MTLS connection. via the pod network, and it pulls that container image. I just put it in a tar. Yeah, that's it. So once I had implemented this, I thought to myself, what about running containers? Can they also be migrated? Why just handle scaled down ones? So as you might know, VM live migration, it's been a thing forever. I think 15 plus years. It basically works in different strategies. Sometimes there's pre-copy or post-copy. It just means that when you make a VM migration, it will copy all the memory of the running VM to a new node. Then it will basically copy just the diff, what has been added to that VM over time, and then there will be a cutoff point where it decides, okay, now I can stop the VM at the old machine, transfer over everything that hasn't been transferred yet. That's the pause time, and then it will continue running. And this sort of pause time, getting that down to basically 0 is the big thing, right? You want to have this migration smoothly that the user basically doesn't even notice it. So I'm using Creo for the whole checkpointing thing, and Creo already technically supports pre-copy. They call it iterative migration. I've linked to their docs here, or post-copy, which is lazy migration. The two can even be combined to optimize for performance. So yeah, we'll do it live. That's the second demo. Let me just delete the first demo. Oh, and by the way, now you'll see that pod, it takes a bit longer than usual to terminate. That's because it actually needs to wait. Maybe there would be a pod to migrate to, right? So it created a migration here. Yes, and now it's unclaimed. After 10 seconds, it gave up. There's no new pod coming, so it just gave up. I'll just clean up these migrations. Okay, and yeah, let me clear that. Create the demo 2. The demo 2 is basically the same thing, same pod, but I changed the arguments a bit of the pod. Maybe I can show it quickly. So now it allocates 1 gigabyte, I think. Yeah, I think that's megabytes. And I've changed the scale down duration to 10 minutes. So this won't scale down until 10 minutes. So I have enough time to live migrate. And yeah, I just gave it a gigabyte of memory. So you can see that how does this affect the actual time for the migration. Let me get out of here. Actually need to uncordon the other node. Okay. Check again where this pod is running. So it's running on the TT worker 2 this time. So I need to drain. No, it's the same again. No, it's the other way around. I need to drain the second one. So it will fail over to the first node. And I'll do the same again. I'll watch the migrations down here. And if I do this, that's it. It's already migrated. Oh, I forgot something. I forgot to put in state. But yeah, let me do it again. So I don't have any data here. That isn't a good demo, right? So let me put in some data live. Okay, now I got data. Now I need to uncordon again. Okay. Now I'm going to migrate again. All right, completed. I can curl, and you see the data is still there. And in the migration, you see it. There's a duration here, and this is sort of an approximation. Freezer, the tool here, it also internally tries to figure out how long was it paused for. It does that by just writing something in memory every millisecond, and then if a timestamp, and then if the timestamp is older than I don't know, 10 milliseconds, it will basically, oh, I noticed something was wrong. I wasn't running for a while, so here the last freeze duration, I think it's around 200 milliseconds, 215, and down here it's 270. And this number down here is from the outside of the process, so it's, yeah, it's always a bit larger. But you can see it, like, it migrated a whole gigabyte of data in just a few milliseconds, but the data wasn't actually migrated during that time. It was slower than that. But it just migrated the minimal state to get the application up and running, and all of the rest is done lazily. As I said before with the lazy migration. I'll get to that in a second. But yeah, that's essentially the demo. So how does this work? Same graph as before, just this small change here. So now we pull the checkpoint, but the checkpoint doesn't contain any application memory. The checkpoint just contains the bare minimum to start the application. In my testing, that's a few kilobytes of data that needs to be transferred. And then after these few kilobytes have been transferred, the container can already be started on the new node. These are these 200 milliseconds that you saw. And then it will lazily pull memory pages as they are needed. This is done via user fault D. It's a Linux thing. Basically, it's so that user space applications can notice when memory access doesn't work, so they can pull that from somewhere else. I think most VM live migrations also make use of that. So yeah, there's some caveats here. Currently, this just does lazy migration. You could do more optimizations by pre-copying, and then you would only need to lazy migrate what is left. But pre-copy also has some issues. It doesn't work on ARM, for example. So yeah. Ephemeral storage is not migrated at the moment. So if your container writes anything to its ephemeral storage layers, this is gone. It can't work with stateful sets because, as you've seen, these two pods need to be active at the same time. One needs to be terminating. It will wait during terminating for a new one, and that just doesn't work with stateful sets because stateful sets, they always wait until the old pod is gone and the new pod has the same name. Does it work with PVCs, so with storage attached? It depends. I did some testing with our storage system, and I think it should work. But yeah, I'm not completely sure this will always work out, because the thing is, the unmount will happen after the new pod is already started. Although Creo makes sure that your application won't run twice. It will make sure of that, but it could be that something else also writes to the volume, and that's usually really bad if you have block storage, if two different nodes write to a single volume. So yeah, this requires more testing. Yeah, read-write many, of course, that will just work. But who wants to use that?
I would like it if it's fast.
That's true. So yeah, one more thing. Live migration only works with one container within a pod. If there's two containers that want to live migrate, there's issues with that because the start-stop order of containers is not guaranteed. I actually implemented all of it, and then it worked, and then it didn't, and then it worked, and I got really confused. And yeah, at some point I noticed, okay, this container is stopping this. This pod is stopping this container first, and this one starts the other one first, and they don't match, so they can't live migrate. And it won't start a second. They don't do it in parallel, essentially. So that doesn't work at all. So it's currently just that just works for the offline migration. Yeah, live migration requires user fault D to be enabled on the kernel itself. Some distributions of Linux, they just don't enable it during build, which I noticed this morning for Flatcar, which we are using. So I couldn't show the demo on a real cluster. Yeah, we need to rebuild the kernel or use a different OS. I think I think most other OSs I checked, like Ubuntu and those kinds of OSs, they enable it. So yeah, what's next? This is very much still in development. I hope I'll release it with the next version of CyrilPod. By the way, CyrilPod is on GitHub. Just check it out. I didn't put the link. Live migration will be optional for now. Yeah, because it's kind of experimental, and it also requires some features that not every Kubernetes node might have. And yeah, there's some patches I actually wrote for Creo. Actually left out quite a bit from this graph because here the memory page is pulling. This is done by starting a Creo page server on the old machine. It's just a component of Creo which serves the memory pages usually over network, but the issue is Creo just binds it to 0.0.0 host network. Doesn't work that great in a container environment because now you need to open ports and it's unencrypted and anyone can just pull these images. It just doesn't work. So I changed it so it can listen to a local socket file, and now I'm doing like a proxy which proxies the socket, and on the other side the same thing. Yeah, it's a bit complicated, but it works. Now all the memory pages are pulled over an encrypted TLS tunnel, so that's good. So yeah, that's it. Do you have any questions?
What if I had open files in the process, like for example, to an image file? Probably the image works because they are probably at the same, or not?
Yeah. So if your file is part of the container image, like of the root FS, that should work fine. Creo will take care of remembering which files were open during checkpoint and recreate those file handles and all that stuff on the new node. And your program shouldn't know that this file should still be open. That should work if the file is there. But if the file isn't there, you're going to run into issues, yes. Yeah. Yeah.
What about migration? Is it possible to migrate between clusters?
He asked if it's possible to migrate between clusters. No. This is, yeah, technically, I mean, Creo allows you to migrate from anywhere to anywhere. It doesn't really matter. It just needs to be Linux. But yeah, this whole thing just works on a cluster. Yeah. Yeah. Thanks.